Okay, everyone, thank you very much for coming here for our panel. The other panelist here doesn't want to be up here with me, for some reason or another. I did take a shower this evening or this morning. No, you don't have to. I'm not trying to peer pressure you to come up here.
I'll be there anyway.
Okay, so I'll be on the other end of the table, because he doesn't want to get too close to me. Oh, are you? Oh, wow, I did special. Okay, so I'll introduce myself and I'll let him introduce himself. My name is Delmar Larson. I'm a professor of chemistry at the University of California, Davis. For the last 16 plus years, I've been the director of the LibreText project. It was originally called the ChemWiki because it focused on chemistry, and we can all agree that chemistry is the best field that we should be studying. But that's what I'm going to be discussing today. Sundar.
Yeah, and my name is Sundar, and I'm a mechanical engineering faculty at University of California, Riverside. And I got involved in the California Learning Lab since 2020, when I got the innovation grant. So I'm presenting some of the results from that activity.
And chemistry is the best field for me.
Chemistry has to be the best.
It has to be the best field. It's great.
I'm not convinced, but I'm sure it is.
There you go. Okay, so with that, I wasn't planning on doing a hands-on because the time frame is not really set up right unless we want to address that with questions, at least from my part. I know Sundar is going to be going to more hands-on thing. But if you scan this QR code, you'll be able to play with some aspects of Adapt on your phone, ready to go. No signing in, just being able to run off of that. And it includes some links to some of the more emerging technologies that we will have integrated to the Adapt homework system by the end of this calendar year. So with that, let me get this thing going here. So if you're unfamiliar with the LibreText project, we have it's not on the screen. I know how to use PowerPoint in case you guys are wondering, but it doesn't look like it. Okay, there we go. I think it.
Oh, you're going to go to the next.
Okay, there we go. Okay, so in case you want an account on Adapt is freely available for any verified instructor across the board. To go to register.libretext.org, you'll get an account. It doesn't happen instantly because we need to verify that you are an instructor, because we want to protect the integrity of the corpus that's out there. So anyways, so if you're unfamiliar with the LibreText project, this is our goal, or this underlying theme of how we view things, and that students are not a market to exploit in order to make an excessive profit off of. The LibreText project has a wide range of features associated with it. However, for the last 4 years, we've been building the Adapt homework system due to several grants from the California Education Learning Lab. The first one was, what was our grant called? An Innovative Award, which gave us $1 million to build Adapt for general chemistry, because we can all agree chemistry is the best field for study out there. And then several years later, the state gave us $4 million to expand the scope of Adapt to include all of STEM, but the state giveth and the state taketh. So they took then $2.5 million back again a couple months ago and closed out the grant because we are in budgetary need. So nonetheless, we are still moving quite strongly, at least in a caretaker mode, as we evolve here. So we have a set of criteria that we want to be able to evaluate when we were constructing Adapt. We wanted to make sure that it was flexible, that it was dynamic, that it was comprehensive, that it was embeddable, that it was LMS agnostic, and that it was powerful and free or nearly free. Now, while the state of California, mostly all 150 campuses in the higher education public systems use Canvas, 50% of the students in America do not. And I have a scope that extends beyond chemistry, and I want to make sure that what we've established works, beyond California and beyond chemistry. We want to make sure that what we have is an infrastructure that works across the country, because that's part of our sustainability model that I can talk about in the questions and answer here. So we tried multiple times in order to build a homework system, or at least partner with people, but we always had issues, primarily mission mismatch. people looked at our traffic, because we deliver about 1 million page views a day. And then they looked at how much money they could make, if they were to monetize that. And then now we started to get into some conflict with the goal that I mentioned before. So Adapt has been growing quite steadily over the last 4 years. This shows you the traffic over the last close to 4 years, including the current year, which is only halfway through. If you project that up to the end of this year, you can see that we're growing pseudo exponentially, and we're very happy with that growth. And that includes not just chemistry, although we all agree chemistry is the best field of study out there, but a wide range of STEM fields and even non-STEM fields. What's out there? So what does Adapt do? Well, Adapt has two different perspectives in terms of how we classify our questions. We have questions that are either auto-graded or questions that are open-ended grading out there. That wasn't a chemist, by the way. The open-ended grading is a relatively easy component of Adapt. That's the one that requires humans in order to grade. Those can be instructors, those can be TAs, those can be explicit graders that come in order to be able to process that. Students submit rich text, files, Excel files, pictures, audio files, and then we go through in order to evaluate it. We build a system up that resembles Canvas's Easy Grader. We call it the Open Grader, and has a bit more power than the Easy Grader, in part because it was my TAs that helped hone it. And if my TAs had to do more work than they wanted to do, they made it clear that they didn't want to do that and had me change the system in order to address that. What is more interesting, at least more complicated to discuss, is the auto-grade capabilities of Adapt. It actually capitalizes on the sharing is caring model that underlies OER and open source technology. So it's created something that's useful. You then capitalize on that in order to make something more productive. I mean, it's not actually more productive, but for your project. So in regards to Adapt, that meant taking 4 existing technologies or protocols and put them underneath the same envelope. That's iMathAS, which is the technology underlying MyOpenMath, which you may have heard of before, which is a beautiful open source technology created by David Littman up in Pierce College in Washington State. It integrates WebWork, which is an infrastructure that came out of upstate New York back in the middle 90s when the word web was very exciting, and is a combination of web and homework, in case you're interested in that. Both WebWork and iMathAS are very powerful technologies for algorithmic based capabilities, and is great for text-based questions. As such, H5P is a more modern technology that is formulated around graphical descriptions, graphical formulations, drag and drops and things like that. It comes from north of the Arctic Circle in Norway, but was just recently bought out by Desire to Learn. It's a learning management system. And then native technologies are classification for a range of different technologies. Most of them are QTI. It's the last acronym I will be using today. QTI, if you're unfamiliar with it, is Question Test Interoperability. That's a protocol underlying Canvas's quizzing. Not the new quizzes, because you shouldn't be using those anyways, but the old original quizzes are QTI. So if you have a question bank in Canvas, you can donate them to Adapt. That's a hint, in case you are catching that. But we have other things that we fold into native, and you can see that with the QR code that you scanned already. That includes our organic chemistry sketcher that we folded onto native, a virtual anatomy or virtual dissection infrastructure for anatomy classes. We will be folding into that other technologies, including what we call Discuss It, which is basically a voice thread or course or flip grid based system. Are you guys familiar with those terms? Those are actually companies, by the way. No responses. Just pretend I didn't say that, and then we'll just move on from there. So the idea here is believing that there is no one single technology that's able to handle all the different needs that we have out there. The technology to handle chemistry is different than the technology to handle accounting, which is different than the technology to handle anatomy, which is different than economics, et cetera, like that. So let's not try, and let's not push it. Let's take the multiple technologies, put it all within the same envelope and the same interface, and then use it as constructively in that manner there. Adapt is designed for multimodal application. You can access, once you make a course in Adapt directly, or students can access it directly through the website, which is what most students do. You can provide those links manually to the students, or they can link, or they just sign in order to access their homework directly. Because we have a textbook infrastructure within LibreText, you can also embed the questions directly into your textbook. So in other words, your textbook becomes what I refer to as the textbook of the future, which is a textbook of technology. Now, if you're like me, you believe your students may not be reading the textbook as much as you want them to. You make your textbook into a homework system, and I can guarantee your students will be at least looking at your textbook while they are solving up problems like that out there. And you can embed your textbook into Canvas if you want to go about reading it that way too. We will have a phone app released very soon. 50% of the students that access our textbooks through the phone. So let's bring trying to remember the analogy, the mountain to the people, and bring the technology to the students instead of trying to force them to use a different technology than they're comfortable with. But the nice thing about this infrastructure, it also provides the capabilities for instructors to use Adapt as in-class polling system. If anyone's ever taken a look at the cost of iClickers today in the classroom, it's almost the same as the cost of a homework system. This provides an additional aspect of what Adapt is capable of doing for you. And lastly, irrespective of how students interact with the Adapt infrastructure, we can pass back scores directly to learning management systems via LTI. I know I promised no acronym, but I lied. Or what's called API, which means application programming interface, basically a more powerful interface to Canvas than these things. So this is all in place. We have, I believe in the community colleges, which is easier for me to count, even though it's a much bigger number, about 90 of the 115 campuses that have already hooked up to LTI. The UCs are much slower for a variety of reasons, and the CSUs have 3 or 4 campuses that have already hooked up into it. I mentioned the phone app. This will be available on both the Android and the Apple stores to give you a different interface to our infrastructure. This is eventually going to pull up a question, and naturally it's going to be a chemistry question because we all agree that chemistry is the best field for studying that's out there. So there it is, and that was a distillation question that was available. So Adapt is designed for multimodal use. So we can deliver questions in a more traditional sense where we have courses have assignments have questions, those questions are opened, or assignments open at this date and this time, closes this date and time. So what we're mostly familiar with in terms of operating a homework system. However, you may be wondering, why do we call Adapt? Well, that's because it has some adaptive learning capabilities to it. So instead of giving a question, we can give a learning tree. Now, if you're unfamiliar with the spectrum of adaptive learning technologies, there's no one technology that says this is adaptive learning. You can have, on one end, a black box algorithm-based system that spoon feeds responses to students based on a profiling that's in place. That's actually quite beautiful algorithms in place for that. But on the other end, you have a white box based approach, a decision tree based approach, or we call them learning trees here. So instead of giving a single question, we give a question with a backup set of nodes. Each box here is a node that deals with exposition or assessments. And the idea behind here is to do the role of what a virtual tutor or what a tutor does in person, which is, here's the question, you need to know this, provide the capabilities out there, and the tutor will help to evaluate whether that student has, which one they need to go down, right? And that's what the black box does. But in contrast to the black box approach, we essentially have something that's more akin to a choose your own adventure story. I'm not sure if those books still exist these days, where students actually guide themselves around the tree itself. So that gives 2 specific aspects that are different from a black box. First, actually, before I talk about that, it's much easier to implement. That is a lot less money, and it's a lot more likely to be productive because those things are actually difficult in order to implement. But to get into the other 2 things, one is that this facilitates metacognition skills. So students have to decide what of these branches that designates specific skills are the ones that are most likely why they failed that question. So it gets them to think more than being a spoon-fed baby on the other end of the spectrum. And metacognition is a particularly difficult thing to teach our students, irrespective of AI and all the other conversations put out there. We have to get the students in order to think about what is most effective for their time. That provides. The second one is this facilitates engagement. So the more likely the students are engaged in the material, actively involved in it, the more likely they're going to be learning from the material instead of being spoon-fed the result that's out there. which is again, one of the concerns that we have about AI and not going through all the hoops that we expect people to do, including even paragraph essays. Yes.
Yeah. Regarding the learning tree, are those manually included or summarized by AI?
Those are currently manually generated static trees that you evolve on to it. We can use AI, which we haven't implemented, to help facilitate that. You could think of this as basically a little mini concept map. So for the longest time in my teaching, I've been trying to figure out how to use concept maps in my class, and I couldn't figure out how to use it. Students don't want to see this mass of how everything is connected here. There's no pedagogy how I can actually try to force them to go about doing that. But here I can give them a snapshot. They can say, well, here's a question and it involves mastering this, 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 and this. And now you have a little image. So you can have them get little pieces of the concept maps as they move. And that's the best that I can envision in order to be able to see a bigger picture out here, because they do see the bigger picture out here. So it's empowered for engagement, it's empowered for metacognition, make them think better and move better. And I will also mention this right here, in contrast to the traditional approach, gives you learning. Because the traditional approach tells you their performance. Here it tells you learning because you can tell what their pre is when they take the root question. They go into the tree and they come back out again, they get a do-over to do the question again. And now I have a post. And now I'm seeing that the students that interact with the tree learn, which I have lots of data in order to argue that. The issue is that you do have to create the trees manually. It can be a little bit painful in order to go about doing it, but once you've done it, you shared it with everybody, you can go and take a look at 450 or so trees that are currently available. Most are in chemistry because we can all agree chemistry is the best field for studying out there, but there are a few other ones that are out there. Yeah, I know mechanical engineering. I'm sorry.
Yeah, so with respect to the tree, I guess 2 questions. One is, can students navigate the tree?
Yes.
However they want? They
Yes.
can go backwards, they can revisit, they can do.
They can go in linear paths. They can go in linear paths up and down. So if they come down here, they go up and they come back down here. So one of the bigger issues we had in constructing this was how to make this not clumsy. Because it's a lot of information to share with it. So at one point, we were trying to hide what they can actually see, like old video games where you had a little map, you can only see the little part, and that worked poorly. So we said, okay, let's just show them everything. As they go down each node, they're only allowed to go in steps. So you can't go from the top to the bottom.
Right, but they could go, let's say, down the left path.
Yes.
Then go
and they
back up to
and
the
they
second node and go down the middle path.
Yes. So the criterion that we have for the incentive in order to have students engage in this, besides the points that they have, is the do-over. So that we say, okay, you failed here, we'll let you have a good do-over, full points, but you just need to be successful in the criterion. The criterion that we have, it can be X number of paths from top to bottom. Typically we do 1. They come down, each one of these things, whether it's exposition, which is a red thing, that could be the text or video or guided inquiry or something like that, whatever it takes in order to do that. And then we have some sort of evaluation step at the end to say, did you actually learn that specific skill? Or at least be proficient in being able to, and this is, hooray, now you could do a do-over. They go back at the top and they didn't do it well. Well, when they get back again, they keep on down to a different path. They keep on going down a different path and interact with that.
And then do you collect data on the visitations?
We have lots of data. Dissecting the data is a different story. Because this is basically trajectory analysis, and trajectory analysis is actually very poorly developed in the analytics infrastructure out there. A lot of it is just descriptive. Did you see this with probability? What actually works better for this is single molecule spectroscopy in order to be able to describe this sort of description of it. So anyways, so let me tie this all together into one big picture. We have a range of different technologies. Again, you saw them with the video, or you have that with the QR code that's out there. It's all pulled into Adapt. Adapt you can access directly. You can access it via your phone, or at least you will be able in a few weeks. Once Android or once Google or Apple is happy with me. Textbooks, you can embed them in there, and then they can all pass back the scores via the learning management system. This is a quick snapshot of a chemistry problem, because again, we all agree, I can't even read it, but it's probably a thermodynamics chemistry problem, something subliming. This is using WebWord. And the key point here is not recreate the wheel. We don't need to build an infrastructure for evaluating and doing this stuff, because the stuff already exists. So we've integrated web work into here. We have it via dynamic load leveler, which means as more students access Adapt, the more it spawns in order to handle the need, which is important as we discovered the very first quarter that I taught a 500 student class with all my students access the class at the same time. Adds complexity to how it operates. Every student gets a different number because it's algorithmic. So the value is different here. This is an instructor viewpoint, so I have some details associated with the side of the performance that's out there. This right here is the easy grader. Again, an instructor view is out there that shows a specific student, which is probably a FERPA protected here. This is not the real name of the student. This is what the student saw. This is their performance. This is the answer off of here, and you can use it to facilitate effective grading. This is what my TAs were critical in terms of honing for us. We just released this summer our adaptive learning infrastructure to guide instructors in terms of how the students are interacting with it. In the simplest form, has the descriptive performance, individual student performance compared to average up here. I'm about to get done. You're not stressing?
No.
Okay, good. It also can track not just scores, but time on task or time in review, whether it's time spent before the deadline or time spent after the deadline. What we're discovering is that students don't look at the questions after the deadline. And they're not using it as a educational resource like they really should. I'm trying to figure out ways in order to facilitate that. It also gives us the ability in order to look at learning curves. This is very similar to how the Open Learning Initiative had to put things in place there, but it needs a bit more data in order to be able to generate good learning curves. And it helps us to be able to identify at-risk students based on the performance. We estimate that with about 80% accuracy, we can identify if a student's going to fail the class within the first 2 weeks based on the performance here. This will also couple information from how students interact with the textbook, because we have both streams that can combine together in order to be able to get more home data. So anyways, let me end with what I started. Actually, I didn't give you this mission statement, so I will give you my mission statement since I didn't put it in the beginning. We're implementing a community-built platform for the construction, curation, adoption of OER, specifically open questions within the ADAPT homework system. It's comprehensive, can be curated at multiple levels. The most popular class on ADAPT is actually Spanish as a second language. Then comes chemistry that's out there. So with that, should acknowledge where the funding comes from. Most of this came from the California Education Learning Lab, although we received some funding from the U.S. Department of Education, a little bit from NSF, and I should thank my campus, because my campus lets me do what I'm doing here instead of playing in the laser lab, which is what I really should be doing by my colleagues' opinion. So with that, I will step aside and we can hear the alternative to ADAPT.
I have a question.
Oh, yes.
Do you have a graph that shows learning curve?
I can dig up something like that. Are you familiar with learning curves? So the thing with learning curves is that you need a lot of data. So basically, the idea behind the learning curve is how many, you look at the number of times that students have been exposed to a specific concept. And then you're looking at, well, they exposed one time, then they're able to perform better off of there. So you need lots of data to be able to track that. So you're not going to be able to track that for an individual person that just doesn't have enough, or even a class is a little bit better, but you have to get a lot of classes and bring it together and then change the paradigm and do those sort of things there.
You showed 73 enrolled students, right?
For that specific class, probably.
So you should have some sort of.
Well, the thing is, you have to, so if you're dealing with homework, you have to ask how many times do they interact with it. So if you look at like the learning curves that the OLI likes, but they have 10 times. So the idea that you have to have them see that specific concept 10 times. So you actually have to have it at a very high level. That includes lots of different things. If you want to try to do it at a really refined level, you just don't have enough data to be able to create an effective learning curve that's up. Yeah.
By the way, we all graduated. We are not going back to chemistry anymore.
I'm not selling you on it. Well, you have the QR code to give you some chemistry questions just to get you back to it.
Okay, so my name is Sundar. As I pointed out, I'm from the University of California, Riverside, and this is a result of an innovation grant that we got in 2020. Our collaborators were Cal Poly Pomona, Mingheng Lee from the chemical department, and Mount San Antonio College. So our our goal was to improve outcomes in introductory engineering classes. And we picked 6 classes in mechanical, chemical, and electrical engineering, which are common to most undergraduate engineering programs, and try to improve outcomes on those classes. So to just go a little bit on our journey. Okay, so when we started this project in 2020, we started looking at the standard Canvas quizzes and other ways to integrate into the LMS. So one of the things that we tried was SCORM-based packages using a storyline. So we tried to package learning materials, including videos and texts and questions and all that stuff into SCORM package, which we could then get into directly integrate into our Canvas. That worked well, except that the format had some severe limitations in terms of what it could do for adaptability, and also the kinds of questions and the kinds of things that we could ask. For example, we could not do a vector like with 3 like X, Y, and Z components. It was impossible to do a matrix because you need like a 3 by 3 would require 9 different boxes. So there were limitations of that kind. So we realized that was a problem. It was also difficult to change numbers. I mean, we could do some stuff like that, but it was just kind of really limited. So then we went into doing a MATLAB-based software, and this was in the context of a particular class I was teaching. I was teaching a class on numerical methods in mechanical engineering. So it's foundations of like linear algebra, numerical methods such as root finding, bisection, Newton-Raphson, and Runge-Kutta methods, and so on. And so MATLAB was the language that we used, and so that was the second thing that we did. So have adaptive questions, so you can, if you're trying to multiply 2 matrices, you can randomize the numbers into matrices, and randomize the sizes, and then ask the students multiply these 2 matrices. So that was the idea. That worked out really well. There were the significant couple of things. It worked out really well because MATLAB had a pretty strong support for numerical methods. I mean, it is after all a numerical methods thing. So it had excellent support for all the stuff that we needed to do. The interfaces are pretty good. You can create user interfaces. It has good widget support and all that. So we were able to do that. The trouble is that it was a standalone package, which means that there was no communication with the database. There was no way to harmonize it across students. If I made a mistake or if there was a coding error, then every student had to download the package all over again and start. And finally, when the students did the results, it had to be uploaded to the server by them, and then we had to. The grading was done automatically, but we still had to enter it into the LMS manually. So we learned a couple of things to that, and this came across from my experience before, and that is students really need to get mastery over a particular subject. It is not sufficient for a student to get a particular thing done once. It needs to be repeated. Students should have the chance to make mistakes and learn from mistakes. They should be allowed in as long as it takes to get the thing right. But it's also necessary for them to get the thing right multiple times, and at least once. I'd like to see them get it right in the very beginning. So they can try 10 times, but in the 10th attempt, I'd like to see that they get a problem right in the very first time they try it. Like if they're multiplying 2 matrices, they get the matrix multiplication down. And that is what I try to enforce build into the software. So what I challenged the students to do was any given problem, say matrix multiplication, you can try as many times as you want. What I want you to do is to get 3 attempts right. So at least 3 of them have to be right. And of those 3, at least 1 has to be right on the very first attempt. And they could keep trying it till they got it right on the first attempt. So that was interesting because I hadn't really thought about it in that manner. Because ultimately, if you look at how an exam is done, like a typical high stakes exam is done, students typically don't have redos. You take the exam, you get the question right or you get it wrong, and that's it, you move on. And I wanted, and when you get feedback, students often don't look at the feedback, they don't reflect on the feedback. So having this kind of enforcement mechanism sort of helped force students to think about, okay, I need to really target my mastery. I need to really master the subject and get it right in first attempt. And that was a pretty interesting feature. Students appreciated it, and we also saw gains in the exams. So students who did that practice and got that usually did well on the final exam too. So based on that, we finally got to building GESTALT. So this had some of the same features that the MATLAB-based application had, adaptive, and it could do matrices, vectors, and all the gamut of stuff that like a homework system like Adapt can do, at least like all the inputs it can do. It was web-based, and we wanted to have it in different forms. So we could have modules. Modules include things like a static text. It could include videos. It could include presentations like PowerPoint presentations and questions and review quizzes. So all that stuff can be packaged into modules. So that's something that we wanted to build in. We also wanted complex adaptive questions. So so instead of just having one or two answers, can you introduce a lot more logic into it? So let's take an example of a car that is going along a curve, right? So one part of the question could be, does the car negotiate this curve safely? And if it does, what's the maximum friction force? So it's like a two-part question, where the second part depends on the answer to the first one. Can we do that? Can we have questions where, let's say, we are looking at a block that is being pushed up a ramp? Now, if that particular problem has multiple regimes, right? So if the force is too small, then the block can slide down. If it's just sufficient, it will stay put. If it exceeds a certain level, it'll go beyond. So that kind of complex logic, can we embed that complex logic into questions? So that was the other goal. So when we thought about, okay, these are the things we need, then we realized that it will be better to embed that logic in a general purpose programming language. So a general purpose programming language like JavaScript or Python, which has lot of powerful package support, like Python has NumPy and SymPy and all kinds of pandas and all sorts of packages that are available. Can we use that as a foundation so that your questions can be arbitrarily complex, not just questions where you're able to quickly code the answer, but actually build complex logic and have a question that addresses that. So that was our goal, and we managed to build that. And then at the end of it, this runs on the web, so it uses Node and JavaScript and all that, and it uses MongoDB and Open, which is on the cloud. So that makes data analysis somewhat easy.
So can I just ask a question?
Yeah.
So in terms of that sort of requirement for at least doing one or three questions, so the way is that student comes in, they get a question, and let's say it's a one vector by one vector product.
Yeah.
They fail. You might give them a second term or something like that in order to hide them, and then you click a button and then it refreshes it with some new numbers, and then they do that, and you keep on doing that until
they control it. So they would this is kind of tedious. How do I do this?
Welcome to this world.
I think I understand. We can take a look at it later. It's pretty cool.
Yeah. So while you're looking at it, yeah. So that's the idea behind it. There we go. Okay, let me just look at numerical methods, wherever that is. Okay, that's the review for the class. So let me just do try out. And here are so let me just say, for example, vectors. Yeah, and then they can enter this, and then if it turns out I'm going to enter some nonsense. It's wrong. And there is a video that goes with it if they need to do it. And the feedback comes here. It's like, it'll be right there. It says, okay, this one, 32 have been attempted, 12 are correct. And there is another part where it says on first attempt, students get that feedback too.
Is it OER or
This is OER, yeah, it's available on GitHub.
there is a password?
Huh?
Password?
Yeah, so let me, you need to send me, if you can send me an email and I can give you a password. I can give you an account and a password.
Are you afraid of students finding the questions in GitHub? Because WebWork had something like that.
No, because this is adaptive. They cannot look at the question.
Unless they're,
I mean, they can
Unless
look
they're
at the
able to-
question, but I mean, the question changes numbers.
right, but they get the they can get the JavaScript code behind the question.
I mean, if they're that good, I'm more than happy that they're doing that. I mean, if they can understand, if we have mechanical engineering students who can actually reverse engineer JavaScript code, I mean, more power to them.
I have a question. So how do you anticipate to extend this kind of framework to teaching numerical methods topic like stability, those kind of things?
Stability?
Yeah, so those core topics, because these seem to be a lot of prerequisite with the numerical method rather than the subject itself.
So are you saying that there's prerequisites for this, or do you?
I mean, this seems to be the prerequisite for numerical methods.
Yeah, so when we have, we haven't fully implemented some of the stuff, but for each of these topics, there is, the metadata contains the prerequisite information. So we haven't yet extended this to say, this would be like linear systems, right, stability. But we have, for example, extended this, we have like the modules for basic thermodynamics, but we also have modules for transport phenomena, which builds on basic thermodynamics.
How many questions do you have?
Huh?
How many questions do you have?
About 400, 500, but hand curated, right? So, yeah.
I have a question. So one of the things that I encountered with students is that a student was complaining that they spend too much time in class solving student active learning assignments. And I said, well, isn't it great because you don't have to do homework at home? And the student says homework is much quicker. And then I asked, oh, do you use technology? And they say, yes. So I was trying to point like one of the apps at your problem and see if AI can solve it.
It does.
So do you have any concerns that they kind of?
We do.
Glad you got that question, not me.
No, we do have that concern, but these are low stakes. But one of the things that we have to emphasize to the students is what are the stakes involved here? This is a low stakes assignment. This is like all of these things put together. This is an extra credit final review. This is supposed to get them ready for the final exam. And it was released maybe 2 weeks before the final so that they could get all the practice done for the final exam. They can cheat on this if they want. They'll get like 3 points extra, but but the final exam is still in person, still our old traditional exam. So I can see if you don't know how to multiply matrices for the paper. So that's something that we do tell the students. And it is a concern, you're right, but it's but on the flip side of it, we are actually able to use that AI to actually come up with the code for this. So let me show you this. Well, I mean, here is the other one. Oh, I'm sorry.
Sometimes it makes mistakes. The AI, it could be subtle. So if you have tolerances that are not like super broad, you can actually sometimes catch these things. Or what I'm trying to do is I'm trying to bake it with lots of data it says so in chemistry, which again is the best field out there, right? You can give lots of different data, like, here are 10 different data and trying to get it to go a little awry, which is useful for students because students are immersed in, lots of data. They should learn what's good and what's important for what they need to do. And that can help push AI off track.
Yeah, so for our purposes, though, we are harnessing AI to be able to build some of the backend software, because the more complex a question gets and the more complex the logic gets, the more time it takes to actually write it out and also debug it. And especially in cases like the one that I pointed out, where you have, say, a force pushing a block up a ramp, you have tons of cases and you have to make sure that for every case, for every angle, it works out right and get all the ranges right. So a question of that kind can take about a day to do. So in order to kind of shorten that time frame, especially for questions which are more run-of-the-mill kind of questions that I showed you, we started using ChatGPT. So, for example, keep doing this. So this is, I mean, these do you still have your question, Irma? Do you still have your question that you put up for chemistry?
It should be in the PowerPoint file, but it's not on a browser because it was just a screenshot. Oh, you actually want to test it to see?
Yeah, I just want to see if it works.
The URL is on the first page of my PowerPoint file. If you want to grab
Which is it? Well,
panel. Yeah, that one there. And if you look at the first page, the first one,
oh yeah, here it is.
that's the image. Do you want the actual text?
Text would be nice.
Yeah, if you go to the top. Oh, actually, that may not have that text.
Any question?
Okay, then go to the very top, the first page. Click on that and there, use that URL. That's the QR code that I just showed. And there are a few questions in there. They may not be as sophisticated, I think. But it'll just show it up in a browser. Doesn't require signing or anything.
All right. Or maybe make up one.
Make up one?
Yeah. Make up one.
But you want a numerical based one.
Yes.
If the heat of sublimation for
Yikes. Oh no. Just check my, oh, okay. This is really awkward. Okay. Uh-huh.
yeah, of a substance is 27 kilojoules per mole. And the heat of vaporization is 200 kilojoules per mole.
Okay, I'll fix my typos.
What is the heat of fusion? And I hope that's actually not a negative number. Obviously, I came there.
No.
What is the heat of fusion? Actually, it's going to come up with a negative number. It's going to be not real, but yeah.
No, the question really is, let's try that. Vaporization.
This is using the ChatGPT API.
Yeah, so it will, let's see what it does. I pulled it.
Well, looks like.
Okay. And I'm just going to say chemistry is relatable.
And finally, someone's listening to me.
All right, so while this gets this done, so this goes in and generates all the files required, because just like iMath.AS or any of these programs, it's going to require that you have a question stub that looks like that, and it requires some logic to be able to replace the numbers and check the right numbers, generate the solution, and so on. So we have examples which we hand curated, and we are now able to pass in an example to the model. Is it done already? Okay. All right, let's see what it did. Let's see if this is right.
You should have been the one making the questions.
Okay, if the heat of sublimation is that right? Does it even make sense?
Yeah, I mean, it's not physical, it doesn't make physical sense. It should be the difference between the two. Yeah, that's correct. That's the,
Okay.
it just is, the numbers are not right for,
Okay,
so.
okay, so the point is like if you,
went wrong in the question.
huh?
Kilojoules per mole.
Kilojoules per mole, right? It should be, yeah, I should have, yeah, what's the heat of fusion? I should have actually.
You had written kilojoules.
Oh,
I
it
did this
removed
to
it per mole, yeah.
Yeah, yeah, okay. But what is neat about it is that I can modify these. So here is the code for it.
How long did it take for you to build this?
To build this stuff,
Yeah, to actually make it so it's able to generate a question like this. Because we're doing something similar with web work, that's what we're starting with.
yeah,
It's just taking a lot of time in order to do it.
yeah, I mean, so you mean the AI stuff or the actual?
The AI, you're doing some prompt engineering.
Yeah, that's taken about like a few months maybe. Yeah. Yeah, so so that's an example of, this is, I don't know, if this is simple or, yeah, it might be quite easy to do this particular question, but but what we have done is we have a whole range of questions with varying complexity, and the prompt engineering part of it is where, yeah, the question is matched to one of those questions, and that question is given as an example, as a template. And the AI then looks at the template and then generates the questions and all the files based on this. It simplifies the task. I mean, it doesn't eliminate our job. I mean, we still have to go back and make sure that the numbers are right. We have to make sure that the logic is right. We have to make sure that the range is correct. I mean, for example, I don't know the range for heat of fusion. It might give some random rate of heat of fusion, which might be outside.
Typically positive is one.
Right. So, yeah, so we have to go in and sometimes do that, or we have to enhance the prompt. But for most of it, we are able to get down the time that it takes us to create questions. And once we are able to create these questions, then assembling that and putting it into those kinds of modules becomes a relatively straightforward task. Yeah.
Can it read images?
Huh?
Images?
Yeah, so it can, so we are able to, there is a separate interface for that. It's in there somewhere.
So you have an OCR
Yeah.
system to convert.
Yeah, so there is a separate one where we are able to.
Well, what type of images? I can understand like the image that I had in my question, that's just OCR and characters.
Yeah, so something like that, or it can also do, it can also pick up an image, like a typical textbook question. There's a question with an image in it, and then sometimes there's a solution. So it's able to kind of recognize that, okay, here is a question with an image, and here is a solution, and that solution might have its own images. For example, there's like statics questions typically have a free body diagram.
It will create the image?
No, if you give it.
Okay,
Yeah.
okay.
At this point, we haven't created images, but the GESTALT itself can create images. So we use SVG to generate and we use SVG and parameters to generate the image.
Because I have seen statics statics course in there. That's why I was asking.
Yeah.
Operationally, how does it work out? Does the faculty sort of write things and the TA codes this up, or
at this point, yeah. So the faculty can write it, the TA, or sometimes the students themselves. Like the person who did most of this stuff, he's taking his own. Like he's a student, and he is taking the classes that he's taking, to getting the solutions from them, and then scanning them and creating the questions, including he's in my class too. So he's been doing that for my class as well. And basically looking at what the limits are. Obviously simple stuff, not a problem. The more complex you go with like lots of intermediate derivations and like
you get to learn JavaScript and Python.
Yeah.
You get to learn JavaScript and Python while doing this.
Oh yeah. Okay, so just very briefly to talk about some of the results we got. The results are very promising. As you might expect, students who are actually students who are involved in use adaptive practice tend to do better. And so the way we did these studies is on the midterm, there was no adaptive practice available. So the students, they didn't have any software available. They just studied for it. Like, for example, mechanics and materials, whether they use the software or not, they had a 50%, and students who used it tend to do better. Of course, one of the things could be that the students who did this would have been more conscientious and wanted to improve, so they might have improved regardless. But that's a general trend that we see. So students who tend to use these kinds of tools tend to do better. Again,
Another question.
Quick question. For example, the question generated by ChatGPT has a wrong unit. And how would you fix it how do you fix it later by fine tuning or by changing the template?
So for now, we have to go and modify it. So that interface there had a, so this particular.
Modify the question that was generated.
Yeah, as you can actually modify it right there.
You mean editing the JavaScript?
You can edit the JavaScript there. Yeah, and then once it's edited, then it's you download the whole thing as one zip file, and then it gets into the GESTALT system.
So in ADAPT, we use WebWork and IMathAS for doing those things. WebWork is Perl based and IMathAS is PHP based. But if you want to do anything that has these sort of sophistication, you need a powerful language behind it in order to do it. Which I presume is the reason why Canvas, which is probably what you started with, was unable to do anything.
Canvas, we couldn't do anything more than like a simple closed form equation.
Yeah, it's just too stupid to do these sort of questions.
So I was at a community college where they let me put anything I wanted. Canvas site, like the LTI, like you can do all the tools, but now I'm at Berkeley and you can't do any LTI integration with anything.
Well, LTI
Or, like,
1.3 no longer gives you the ability to add anything you want to your.
Yeah, and there's like a gatekeeper
Right.
that will not let you integrate anything that's not approved by Canvas, basically. So is that just a Berkeley thing or is this a UC thing?
No, the UCs have, community colleges are a little bit less restrictive. The CSU's a little bit more restrictive and the UC is particularly more restrictive. So if you want to get into other campuses, like I said, we're in 100 and whatever plus campus, you need to make sure you have, I don't know if you really want to know this thing. You need FERPA documentation, you need security, HEPVAT, you need privacy, you need to go through lots and lots of hoops in order to do it. It can take a long time, but the actual process itself is about a 20 to 30-second click of a few numbers on the back that the Canvas administrator needs to do.
Well, yeah, but they won't do that.
Right.
For all of that other stuff. They're very concerned about student data.
Right. Protections and things like that.
Yeah, we went through that with our IT and our teaching learning center. And I realized that I could spend months trying to do that or actually get more functionality into this and just have the instructor. Because most of these, the Canvas, for example, does have the ability to upload student grades, right? So we just use that mechanism. So this
That's what
fits out.
you still use that?
Hmm?
You still use that? Or do you have LTI?
No, we still use that.
Okay.
So the students do this on their website and then they have to upload their.
So they don't have to do anything. The instructor can then just like click a button and then it downloads the student's grades. And that's then uploaded to Canvas
So you get a CSV file that you then
Yeah.
can upload manually.
manually.
So about 50% of the students, 50% of the courses on ADAPT do it that way, because that way they don't need to care about what their administrators do with their LMSs. But technically it should follow the same.
Yeah, it shouldn't, that's like the same problem because of the student data.
From their perspective, it's the same problem, but it gives you the solution, so you can come in and upload it without having any permission, so you can do that without any issues.
Maybe after.
Yeah,
Okay.
so,
Yeah,
yeah,
it makes it really hard to be innovative.
it's
in this
a big,
space
it's a
if you're
big issue.
limited to Canvas.
Yeah, I mean, you have to handle a variety of things, and I was encouraging the Learning Lab in order to look at that when they were, fostering a lot of projects like ours, because we have the same shared accessibility requirements, we have the same shared security requirements and privacy-based requirements. And each project was sort of discovering on their own what they needed to do. And it was sort of wasteful. It would be better if we had a centralized structure that says, well, this is what you need in order to get into LTI, do this, do this, do this. Here's the documentation, here's the recommendation, do that. Otherwise, it's a very frustrating experience trying to figure out what you need to do, how do you go about doing it, and especially if you're trying to get into the UC system. We are collectively pains in the asses. Out there. Community colleges, they're much better. Not all of them, but most of them. We're supposed to be done in a minute, so if you have a few more questions, like why chemistry is the best in the world, we
I
can
have a
address it.
question like that,
Oh, great.
which is a little bit far-fetched. So I caught one of your sentences saying students hate the concept maps. I'm wondering.
Did I
do
say
you have
that?
Data to support?
No, concept maps are difficult in order to use because you don't have a pedagogy around them. So yes, some of them, some specific types of students like to draw them and really like
Yeah,
to
because
go.
I've seen
Yeah,
students.
yeah, there are some that like them, but try to actually teach them, other than say, draw a concept map and I'll look at it and see, it doesn't work very well as
Yeah.
at scale
I think
pedagogy.
teaching you have to somehow flatten the two-dimensional into a more linear way.
Right, and our perspective with the learning trees is to compartmentalize it, so you're looking at little components. So you have this thing and you have this thing, and you can see how that they're actually connected for handling certain questions. And that those are the ones that they're most interested in, because their goal is to address that question.
Like a tree has a pretty good traversal mechanism, right? So you go from the root to the nodes and then you can back up and do depth first, breadth first. They're like well-defined traversals for them. Whereas like if you just have a concept map, it looks more like an undirected graph where you can kind of move around in any which way. So it might be a little harder to navigate from a software perspective too.
Well, it's not quite the software, it's how do you use it?
Yeah,
You have it, you're like going, well, how do you use this in the classroom? I don't know how to use it. I'm not gonna say, identify 3 things that are connected to this one node and you're kind of building it graphically, but it's not appealing to me as an instructor in order to use it as well. But if you have a pedagogy that will work, I'd certainly be interested in hearing.
I think about.
Okay, please let me know. Yeah.
I have a question. So how far are we from technology that would allow instructors to create a piece of code that they can complement to a LMS, say that would implement a specific activity in the class? So I'd like to have open-ended problems where students critique each other and submit critiques, and then, all of that happening conveniently. Of course, I can accommodate using what LMS given me, but it's not convenient technologically. There's lots of cut and paste and creating different assignments. I just want to say, hey, AI, this is what I have in a plan, like the workflow, right? Can you give me H5P for that so that I can just.
Let's stop there. There's a lot to unpack. I'm trying to figure out what part to address first.
So, yeah.
So in terms of interaction, I mentioned that we had this voice thread and we call it discuss it questions. And it was designed and paid for by Spanish as a second language instructors from Chicago College. And I'm going to be implementing in my class, and the idea behind it is you have a central core document that you can upload. It could be a question, it could be a PDF, it could be something, and then students interact with each other on the side like commentary, but it's text-based, or it could be video, or it could be audio, and they're able to interact, and you use that in order to do peer-to-peer communication. And that sounded like a little bit of where you were going with that. And that all passes through from ATI and such. But we are rapidly losing our audience, so we should probably close this thing out.
Yeah, okay.
And we can talk about this afterwards. I'm very interested in this. So with that, I don't know what we're supposed to be doing next. Thank you.
Thank you.
Ballroom.
Yeah, thank you. Okay. That's cool, AI. Like I said, we were playing with that, but
Yeah, I should actually put you in touch with my student who can
Yeah.
actually show you, because it's the same, your structures look different, but
Mhm.
it's the same kind of a philosophy, right? So you need a question stub, you need metadata, and you also need some sort of logic that populates those questions with the adaptive numbers. So if it's the same philosophy, then.
yeah, I just need to see how. Yeah, I would love to do it. We have lots of examples that we use. Basically,
you have
here, yeah, so we have a lot to do this stuff. We just. We haven't quite figured out exactly what we want to do, and I want to be able to take something like all of the text-based questions and convert them over. So you can take a lot of text-based questions and use respondus in order to make QTI-based questions, but they're dumb QTI questions. I want to be able to come in and take like here's a list of questions that some campus has made for chemistry, that's 1,000 questions. But they require sophistication to address it and then convert them to auto-graded, and then at least make it 90% easier, to start
Yeah, yeah.
finessing and tuning and things like that.
Yeah, because creating these questions and proofreading them and making sure that they're perfect is quite challenging.
Painful.
And especially if you make a mistake, then going to fix it, and then the students start complaining, and then you have to fix that.
Yeah, that's why, so we have the open grader, but then right after that, we have the regrader. Okay,
And then
you make a
the
mistake with your question, you need to come in and change it.
And then you read later, yeah.
Yeah,
Very nice.
thank you.
Thank you.